In this lecture, we will move forward towards training the segmentation model. So before training the segmentation model, we need to define the training dataset and validation dataset, and also training data loader and validation data loader. So here is our training dataset. Here you can see the training dataset is equal to dataset, and we have passed the original training images and corresponding training mask. And here you can see we will also apply the training augmentation to the training data. And here you can see also the processing function that we will also apply to the data. So previously we have seen this pre-processing function is used while training the pre-trained encoder. So we will apply the same normalization as applied to the encoder. And also we have passed the classes of the dataset. And similarly, you can see the validation dataset where we pass the validation original images and validation mask corresponding to the original image. And here we will apply the validation augmentation because it's a validation dataset, and we have defined the validation augmentation separate. And again, we will apply the pre-processing to normalize the validation data as well. And then we pass the number of classes. And finally, we will declare the training data loader. Here you can see data loader, and we have passed the training data and batch size equal to 6, and we set the shuffle is equal to true and number of workers 0. And similarly, the validation data loader, we pass the validation data set, batch size is equal to 1. We did not shuffle the data, and similarly number of workers is equal to 0. So after defining the data set and data loader, now you will define the training epoch and validation epoch. So in the training epoch, here we will pass the model that we have already defined. We will pass the loss function that we have already defined. We will pass the matrix. We have already defined the matrix. We will pass the optimizer we have already defined, and also the device. We will pass the device mean the GPU or CPU, and also verbose is equal to true to display the detailed information. Similarly, in the validation epoch, we have passed the same number of parameters. Now you will set the model to training as we have defined everything, and then save the model. So here you can see we have used the for loop to run this model for 500 epochs, and then we have run the training epoch, and then we have also run the validation epoch, and we have passed corresponding train loader to the training epoch and validation loader to the validation epoch. And next we are saving the model with the best intersection or union score. Here you can see the model is being saved on this path. Here you can see you can define your own path in the Google Code Drive. So torch.save model. So the model that is being trained, and it will be saved to this path with this name. For example, we are going to train the unet++. So the model will be saved as unet+.pth. That will be saved on this very path. And also you can change the learning rate. For example, let's say if epochs reach to 50, then decrease the decoder learning rate to this. So you can also change the learning rate during the training. So for the sake of the experimental evaluation of the segmentation models, we are going to train 3 different models. The first model is ResNet unet++. That model basically uses the ResNet 50 encoder and unet++ decoder. And the second segmentation model we are going to train is efficient net FPN model. This model basically consists of efficient net encoder and FPN decoder. And the third model that we are going to train is MobileNet PSPNet. It will use the MobileNet encoder and PSPNet decoder. Now let's switch to the Google Colab so that we can train these models and we can save these models. And later we can evaluate and compare these model performance. So here is the code for the training dataset and validation dataset and training loader and validation loader. So let's run it. So first of all, you need to import the data loader library and then run this code. Then we are going to define some function for training the model. So here is the class meter that will basically provide a way to keep track of important statistics in online manner. This class is abstract but provides a standard interface for all meters to follow. So let's run this code, and it's successful, and here you can see the code, and here is the code to define the epochs. So here you can see the class epoch. Here we have passed model, loss, matrix, and also you can see the other parameters. We have already discussed about these parameters. Here you can also see the training epoch and the number of parameters we have passed. And then again, here is the validation epoch and the number of parameters we have passed. So let's run this code, and then finally we will define the device basically torch.device. So if GPU CUDA 0 is GPU, if it is available then use it, otherwise use the CPU. So here is our training epoch and validation epoch, and we have defined the training epoch and validation epoch, and we have passed the model, loss function, matrix, optimizer, device and verbose, and similarly to the validation epoch. Let's run this code, and here we go, it's successful. And finally we have set up everything. Now we are able to train our model. So here you can see we will train our model for 500 epochs, and here you can see the training epoch dot run, and we have supplied the train data loader, and validation epoch dot run, and we have supplied the validation data loader. And finally the model is being saved with the best intersection over union score. So here is, you can see, the model with the maximum score will be saved. So here is the code to save the model. So here you can see torch.save and save the model, and this is the path to save the model, and we give the model name, and this is the model name unetplus.pth. basically it will be saved with this name to this path in the Google Drive, so that we can use it later for testing. And here you can also see you can change the learning rate as well. So before running this, let's define the UNetPlus model with ResNet 50 encoder and UNetPlus decoder. So let's go to the code where we can define this model architecture. So here is our model architecture. So here we are gonna first use the ResNet 50 encoder with the UNet plus decoder. So let's run this code, and here it's loading the ResNet 50 encoder, and here we are gonna see the architecture. So let's confirm it. So let's see the architecture. So here you can see the UNet++ segmentation model with the ResNet encoder, and let's go to see decoder architecture. So here you can see the decoder is equal to UNet++ decoder. So we are good to go to train the models. So let's go to train the model UNet++ with the ResNet encoder. So let's run this code to train the UNet++ model with the ResNet 50 encoder. So similarly we will train other two models, EfficientNet and FPN. EfficientNet FPN segmentation model with the EfficientNet encoder and FPN decoder, and the third model is MobileNet PSPNet segmentation model, that is basically with the MobileNet encoder and PSPNet decoder. So let's run to train the ResNet 50 UNet++ segmentation model. So let's run it. So here you can see it's training. So here we can see the epoch 0. So it will basically take a time. So let's pause this and we can resume later. So the model has been trained. For example, if you see at the epoch 1, here you can see the training statistics, and also you can see the validation statistics. And in the training statistics you can see the dice loss, intersection over union score, accuracy, F score, and you can see the recall and precision as well. And similarly in the validation statistics you can see the dice loss, intersection over union, accuracy, F score, and similarly recall and precision. As you can notice in the epoch 0, the intersection over union on the validation data set was 0.86, it's mean 86%. And similarly we will train the other two models, and after that we will evaluate these models and we will compare the performance. So in the next lecture we are going to evaluate this model on the testing data, and then we will make a comparison of these three models. So see you in the next lecture.